Cement Stone Contact Areas Hydro Outbreak Determination Procedure, OGK-01. Sealed isolation of the borehole annuals is the prerequisite condition for causing string high-quality cement. This section shows a schematic design of the cemented casing strings, as well as lying in front of it water-bearing, impermeable, and oil-bearing formations. In the absence of hermetical barrier between the formations, flows from the water-bearing formation into the oil-bearing formation will take place, whereby a water cut occurs. Thus, the insulating ability of the lining depends on the cement sheath condition and contact density in the system: casing string, cement stone, rock. Not only the presence of natural water-bearing formation near the bank of oil, but also the use of water injection wells for enhanced oil recovery can lead to flows. This cross-sectional diagram shows us the field scheme with formation pressure maintained through water injection wells. When a well is watered by pumping water, it is possible to use the overlying productive formation. However, in the absence of an airtight bridge between the oil-bearing formations, a flow occurs with further flooding of the overlying productive formation. The presented models show that the main cause of water breakthrough in the well development and operation is the annulus fluid circulation due to the lack or breach of contact zones in the cement stone. In addition to production quality reducing due to flooding, the lack of tightness of the cement sheath can cause the uncontrolled release of the formation fluids to the surface. A striking example of this situation is the accident in the Gulf of Mexico. According to the conclusion presented in the report of the USA State Commission, the main cause of the accident was the poor quality of cementing, in particular, the lack of the cement sheath integrity. Well Casing Service Group of Companies has developed a methodology for assessing the insulating ability of the cement stone contact with the bounding surface. The main tool of the methodology is the instrument OGK-01. This part of the video presentation shows us a three-dimensional model of the device, OGK-01, as well as the principle of its operation. The OGK-01 device is a hydraulic machine allowing to inject a working fluid into the test cell with a given performance to record the variation of pressure. The water is pumped through the filter system in the holding tank and then is pumped into the test cell. The test cell is a specially designed and made of high-alloy stainless steel hollow cylinder, closed with special covers on the both sides. As a result of a constant fluid supply, the pressure in the cell increases and leads to breakout of the contact between the cement stone and the test cell wall. The breakthrough pressure is recorded in the computer program. Thus, the OGK-01 installation enables to assess the condition of contact zone of the cement stone formed in the thermobaric conditions. To demonstrate the results of the study, we have prepared two materials with the linear extension for 1% and 10%. The samples are mixed and dispensed into molds to form the cement paste with further placement into an oven where they shall be stored for 24 hours. Using the threaded connection, the samples are screwed to the OGK device and are ready for the testing. The device is switched on and pressurized. The sensors detect the indicators of pressure at hydro outbreak of the cement stone and display them on the monitor. This pressure chart, recorded by the program of OGK-01 device, illustrates the course of testing of the expanding plugging material with 1% expansion and 10%. The Scientific Center of Well Casing Service Group of Companies has conducted several studies to determine the effect of the linear expansion coefficient on the breakdown pressure rate for the contact. The diagram shows us dependence of water breakthrough pressure on the expansion of two plugging materials. The graph shows that the increase in the coefficient of expansion to 7% is almost directly proportional to the increase in pressure of water breakthrough. Then the slope flattens sharply. In addition to the absolute value of the coefficient of expansion, the value of breakthrough pressure can also be affected by the kind of spreading additive, kinetics, and dynamics of the cement slurry expansion, consistentness with the terms of the setting. This explains the fact that two different expanding plugging materials with the same expansion coefficients show significantly different values of the pressure breakthrough. Thank you for your attention.